This presentation is a visual abstract for the paper titled The Influence of Notch Connection Location on the Short-Term Behavior of Timber Concrete Composite Beams, Modeling of TCC Beams and Research for Optimal Locations, a numerical study. A simulation of 4 points bending using 3D models for 8 TCC beams is established. The beams are composed of LVL timber joists topped with a concrete slab separated by OSB plywood. The geometry, materials, characteristics, loading and boundary conditions of the models are similar to those of the tested beams. A finer mesh was applied to the notch connection and the surrounding LVL region. For the rest of the model, reasonable mesh was used. The LVL timber is simulated as an orthotropic material with the following parameters. The concrete adopted is the same in the experimental program. For that, concrete damaged plasticity was employed, while a bilinear elastoplastic behavior law was used for the steel. The load mid-span deflection curves of the 8 TCC beams obtained by the numerical analysis are on the safe side compared of the experimental curves, which implies the validation of the model. The two types of failure can be displayed: the fracture by the tension of the LVL joist under the loading points, and the shear failure of the connection in the under-designed beams. Based on the validated model, a numerical study was conducted to research the optimal location, considering a TCC beam with a single notch connection located at different locations. 6 locations were selected, while a notch length changed every time from 50 to 200 mm. 24 load mid-span curves for each case are plotted. From each curve, the initial bending stiffness, the final bending stiffness, and the maximum load strength were extracted. To ensure high bending stiffness, the location P3000 was found to be the optimal location for the TCC beam. Moving the notch to this optimal location can increase the stiffness up to 35%. The location P3750 is the optimal location to achieve higher strength, with an improvement up to 30%. The failure patterns are a shear failure of the notch R50 without variation in composite action, shear failure of the connections with loss in composite action, except for shear failure of the Timbre LVL in one case.